Welcome to our first Leetcode session for the spring semester. In this video, we will be looking at problem number 49 from Leetcode, which is group anagrams. This is a medium level question on Leetcode, and it involves using lists and strings. So we can start by looking at the problem on Leetcode. So we're given this description of what our code should do. So given an array of strings strs, group the anagrams together. You can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original word or all the original letters exactly once. So as you can see, we're given one example where strs equals eat, tea, tan, ate, nat, and bat. And then we have this output that's grouping the words in this list. So to solve this problem, we should start by understanding what an anagram is. And we can see based on this definition that we're given, it's essentially a word that can be formed by rearranging the letters of another word. So for example, if we had eat, we can rearrange the letters in this word to form tea. And then similarly, we can rearrange the letters in tea to form ate, right? So all of the three words eat, tea, and ate have the letters AET just in a different order. So they're all anagrams of each other. And similarly, tan and nat can be rearranged to form each other. And bat would not be part of any of these groups because no matter how we rearrange the letters in bat, we're not going to get any of these other words since it contains A, B, T as letters. So if we look at this output, we can see that bat is in one list. Nat and tan are in another list because we can rearrange them to get each other. And then ate, eat, and tea are in another list because similarly, they all contain the same letters, just rearranged in a different order. If we look at example 2, we're given that strs is equal to a blank string. So the output is just that. And then in the third example, we're given the input strs equals just the character A. And we can see that the output is just A, which makes sense because we just have a letter and we basically output that. And if we look at the constraints that we're given, we know that the length has to be between 1 and 10 to the 4th for the array of strings that were given. We know that the word, like each word in the strings array has to be between 0 and 100. And we know that all of the words in this array consist of lowercase English letters. So we don't need to worry about numbers or necessarily worry about anything like symbols or uppercase letters given this constraint. So before we start coding it, we can start by kind of going through one way to approach this problem and going through like the algorithm. That way we can kind of see how to get this form of output. And another thing we can see is that we need to return a list of lists with strings in it, right? So this output has a list of lists, and each list has strings in it, depending on the grouping. So we can start by going through the algorithm. So we can start by looking at, once again, we can look at what the input was and looking at what the output should be. And to start, I will just write what the input was given to us in the problem. So we were given that STRS, this array of strings was eat, t, tan, 8, nat, and that. And then we know that our output as given should look like this, where we have bat, nat, tan, 8, eat, and t. Right, so if we just highlight the anagrams, we can see that eat, t, and 8 should be in one group. And then we have tan, nat in a second group. And then bat would just be in its own group. And that's what we see in the output. So to start coding this, we can think about how can we group, for example, eat, t, and 8 together. Since they all have the same letters, just rearranged in a different order, we can start by first iterating through this array of strings. And then we can use the fact that they all have, at least eat, t, and 8 all have the same letters to help us group them together later on in the code. So to start, we should iterate through the STRS array that we're given our strings. And for example, if we iterate through it and our first word will be eat, right? And this is a string. And what we can do is we can convert this to a character array, which would look something like this. And we can do this using .to character array in Java. And we can just say, this is like a character array. And then from here, what we can do is we can sort this array. And since it's a character array, we would just sort it alphabetically, right? And we can use arrays.sort to sort it. And when we do that, we would get A, E, T, right? And then since we want in the end to have all strings in our list of lists, we can convert this to a string using arrays.toString in Java. So we can make this AET, right? And the reason we're doing this is because when we iterate through this array, we know that later on we will get T, right? And when we sort T alphabetically, we will still get this same arrangement, right? We would still get AET, right? And that's the same for 8, right? It would still be rearranged to be AET when it's sorted alphabetically. So using this kind of idea, this kind of sorting, what we can do is we can have this be our sorted value, right? And because we need to group all of these, eat, t, and 8, for example, together in a list, what we can do is we can create a hash map. And we know that there should be a key and a value pair for this hash map and for any hash map in general. And what we can do is we can place this sorted value in our hash map. AET as our key, right? And we can see that our value should contain the words having AET in it, just rearranged in a different form. And because our hash map originally didn't have AET, we add that as a key, and we need to also make sure to add a new list as the value pair, right? Because at the very end, according to our problem, we want to return a list of lists. So we can have a list as our value pair for each key, and we want to make sure to place the word in this list. And we don't want to place the sorted value because that's already our key, but we want to rather place the original value, eat. So we can place that as one of the elements of this list in our value pairing for this key. And then we would just go to the next word, T, right? We would just go to the next iteration of our loop. And similarly, T, if we go through the same kind of logic, T would just have TEA be its character array. So it would look like that initially, then we would sort it and we would get the same AET result, since when we sort T alphabetically, we still get AET, and our sorted value would then similarly be AET, right? So when we get to the next part, we should make sure to have a check statement that if our hash map contains the key AET, we just add the word, the original word. So we would just add T over here into this value list. And then to do one more example, if we look at tan, right? Tan would be, as a character array, it would look like TAN, right? And then if we sort tan, alphabetically, it would look like ANT. Sorted. And then we convert this to a string and it would be ANT, right? So this would be like our sorted value. And then we go back to the part where we check, does our hash map already have this key? And if it doesn't, we add the key first. So we would add and we would create a new list as its pair for the value. And then we want to always make sure to add the original word to its corresponding key. So we would add tan over here. And so we could follow this logic. So we would just proceed to the next word now, and that's 8, right? So it would go back to creating the character array and then sorting it alphabetically, adding it to our hash map. And we would continue with NAT and BAT in this kind of algorithm. So this is one way to do it. There are several ways to approach this question. This is one algorithm. So now we can proceed to coding it by following this kind of approach to the question. Okay, so now we can start coding it in Java, and we can follow the algorithm that we went through previously. So to start, we know that we need to return a list of lists with strings in it. So we can create a list of lists with strings in it. So we would just do that using this kind of syntax, and we can call it group anagrams. And we can just create, say it's new array list. So this is just creating the return value that we want at the very end, since we need to return group anagrams, the list of lists with strings in it at the very end. And then we know that based on our algorithm, we're going to need a hash map. So we can also create that at the very top. So we can say hash map. We want strings to be our key, and then we want a list to be our value. And then we can just call it map, and we can say equals new hash map. So this is just creating the list of lists and then the hash map that we're going to use in our algorithm. And then we know that the next part of our algorithm was iterating through STRS. So we can do a for loop, and we can say for string word. So each word in this array, STRS, we can iterate through that. So now that we have this for loop that goes through the array, we know that we're going to use a character array, and we would convert the word to a character array because we want to use this character array to sort it alphabetically. So we would convert it to character array, and then we would do arrays.sort array. And this would basically take this character array and sort it alphabetically based on the characters. And then we want at the end, since we want it to be strings in our list of lists, we can just convert this to string sorted value equals arrays.toString of array, right? So this would basically, because in our hash map, we want the key to be strings, and then at the very end, we want everything in our list of lists to be strings, we can just use arrays.toString and pass in this character array that we sorted alphabetically and store it in string sorted value. And then the next part would be to check if our hash map already contains sorted value, and if it doesn't, we need to add the key and make sure that the value that's paired to it has a list that has been created. So now we can, inside this for loop, we can check if the hash map, so we called it map. So if map dot contains key sorted value, and we can say if map dot contains key sorted value, so it has sorted value, then we know we just have to add the word to the list. But if it doesn't have the sorted value, then we need to map dot put the sorted value, which is basically like our key. So it would be like AET, as we discussed in the algorithm. So we need to place the key, and then we need to also create a new list, right? Because we need to add all of the anagrams to this list. So we would do new array list. And this line is basically just saying that if our hash map does not contain the sorted value key, then we need to put the sorted value key, so AET, we need to put that, and then for its value pair, we're creating an array list, so that in the next line, what we can do is we can do map dot get sorted value, and we can add the the word over here, right? So we want to add the original word because that would be like eat or tea or ate, right? So that way we would be placing these words in this array list that we created for the sorted value in this hash map. And then the next part would just be to finally just group all of these lists that we have in the values of the hash map together so that we have a list of lists with strings in it. So to do this, since all we're really concerned about at this point is grouping and combining the lists of lists together, which is stored in the values pair of our hash map, we can just use map. We already did map.get, so what we can do is we can do group anagrams dot add all, and the add all method would just take all of the elements that we specify and place them in a collection. And we're saying we want to place them in group anagrams that we already declared at the top. So we would do group anagrams dot add all and map dot values, and this would basically combine all of our lists in our hash map values pairing and put them together in group anagrams so that it's a list of lists. And then at the very end, we need to make sure we return group anagrams. And yeah, so now we can test this code out and see if it gives us the right output. So we can run code. Right, and we see that we get the expected output, and then now we can submit. Let's see. Right, so we can see that the code was successful and our algorithm worked. So yeah, so this is basically one approach to coding this problem. Over here, I kind of went through the algorithm, and here's some like notes about going through the algorithm and kind of approaching this problem. What we did essentially, to recap over here, was we created the list of lists, group anagrams for us, and then we created a hash map with the key being the string and the value being a list of strings. And then we started by looping through the list of strings given in the problem and sorted each word alphabetically. We then checked if the hash map contained this sorted word as a key. And if it didn't, we put a new array list at the key of this sorted value. And then finally, we added the original word to the values part of the array list at this key of the sorted value. And then we converted the values of the hash map into one list. And so that's basically like a recap of what we did over here. And that's about it for our first Leetcode session. So thank you for watching. These slides will be posted in the description of the video. So feel free to come back and go through the algorithm, and I'll be posting the code as well. So feel free to also go through the code once more. So thank you for watching.